I want to look at several different areas where a web server can be configured insecurely such that it leaks internal data, and more specifically, where that internal data poses a serious security risk. Now, I'm back on our sample insecure site here, and I want to give you an example of just what I mean by this. I'm going to scroll down the page a little bit, and I'm going to select View NISNs. Now, when this page loads, you'll see there's a query string in the URL, order by equals supercar ID. Now, I'm going to drop a malicious payload in over that supercar ID value, and the payload looks like this. Now, this is a SQL injection payload, and I show exactly how this works in my Ethical Hacking SQL Injection course. So we're not going to go into detail on the mechanics of SQL injection here. Instead, I want to show you what happens when this page loads. So here we go. This is an internal exception that's been raised by the application running on the web server. And what the exception tells us is one of the passwords in the database. It's this one, password with a 0 instead of an O. This is just a simple error-based SQL injection attack. And an error-based SQL injection attack is dependent on the underlying error that the database raises being exposed in the web interface. Now, in order for that to happen, the web server has to be configured insecurely such that internal exceptions are sent back to the user's browser, which is exactly what we're seeing here, an internal exception. Now, it's important to show you how this gets exploited, because sometimes people see an internal exception that's not really of much consequence on its own, and they say, hey, this isn't really a security problem because there's nothing of a sensitive nature in the exception. But when you combine that with another risk, such as a SQL injection risk, that's when you get what we've got here, which is now a readily exploitable risk. We have someone's password. And using this approach, we can get all of the other data for that person as well. So we could now log on to the service as them and probably log on to other services where they've reused the password as well. So leaking internal exceptions, and particularly these verbose error messages like we see here, is a very good example of internal leakage. And it's one of the things that you want to look for as an ethical hacker, and that you definitely want to disable when you're protecting a system. So that's one example. Let me give you another example. And I'm going to just change the URL to this. This is going to load Almar, the error logging modules and handlers. And Almar is a very popular error handling library for ASP.NET. Here's what happens when we load that page. What we're now seeing is internal exceptions that have been raised in this system, and they're now indexed and searchable with Almar. And in fact, we can see the error that I just raised down here on row 3. Now, one of the curious things about this is that there is someone else using this system also raising exceptions. That'd be the first two, and all the other ones that aren't related to password with a 0. But again, that's the design of the site. It's a publicly accessible, deliberately vulnerable site that you can go and use for security education right now. Now let's drill down into that exception that I just raised. And here we have quite an extensive amount of information. So this is the internal stack trace. It gives us things like the path on the host where the exception occurred. If we scroll down a little bit, we see the server variables. And the server variables include things like the cookies that the user sent with the request. Now, as I explain in ethical hacking session hijacking, frequently these cookies will include sensitive data such as the auth token that's used to identify the user when they make requests to the site. If you can get hold of that, then you can recreate that user's session and effectively browse around the site as if you were them. So the lesson that this Almar example teaches us is that log files must have appropriate access controls. They should not be anonymously accessible. And let me give you an example of just how prevalent the problem with Almar is. I'm going to paste in a a Google Dork search here. And a Google Dork is simply a very carefully crafted search term that exposes data on the internet that is not meant to be found. Now this Google Dork is looking for Almar, and it's commonly represented with the AXD handler. So that's why we're looking for in URL almar.axd. We're qualifying that the file type must be AXD, and we're looking for error log 4 because that's what appears on the Almar error log page. Let's see what happens when we search for that. And we get 15,500 results. These are all publicly exposed Almar logs. I've obfuscated the URLs here because these are live running websites that do make their Almars discoverable via anyone. Google has gone and indexed these. So this is a great example of just how prevalent this problem is. Thousands and thousands of websites with their sensitive internal logs exposed. And that's just for one error handling library in one application stack, being ASP.NET. There are many other examples for other libraries and other frameworks. Now, one more example I want to give you. Let's quickly jump back to a screen we saw in the previous module on discovering risks in web servers. And I showed this. This is Burp Suite, and I'd used it to enumerate known file paths, effectively doing forced browsing, so checking if all sorts of different possible resources might exist on the site. And I pointed out these three: backup.zip, database.zip, and database.back. Now, one of the things that frequently happens with web server misconfiguration is you see database backups or backups of the website itself stored on the website itself, so easily accessible over HTTP. So for example, that database.back file looks pretty interesting, particularly given it's nearly 7 meg in size. Let's go back to the website and see if we can load that. I'll paste the URL in here, load the page, and yes, it looks like it's downloading this file, database.back, which is probably pretty self-explanatory. And again, this does happen a lot. And there are Google Docs that you can use in order to find this sort of resource as well. Now, clearly that will find it in other people's websites on the public web. So you do want to be a bit cautious about that. But as an ethical hacker, you want to be looking at the sites that you're testing for common backup resources. Certainly, if you're responsible for maintaining a website, you want to be very, very certain that you're not seeing backups of anything on the live website. The only thing the live website should be serving is the live website itself, not backup artifacts like this database file. So they're 3 quick examples of internal leakage. Let's move on and have a look at what can go wrong with debug settings.